day 950 off the grid, and I've pretty much put a solid day's work into the transfer switch, and it's basically complete and ready to go. I've done the testing and it's looking really good. I'll probably get it mounted tonight and at least half of it working. It's been another one of those days where, let's have a look out there, started out like it was going to be a generator day, but then it just became really nice, which is kind of backwards from what we'd normally expect around here, and it's been like that for quite some time, last several days pretty much, so not complaining. It just means I probably won't be running the generator tonight to really test this, but time will come, you know, time will come. So what have I done that's changed from the original configuration? Well, for one thing, this relay here and this relay are completely separate, apart from the fact that the coils are controlled by the same circuit. So this one here works with these inputs here on these white cables, and the output is this main socket here. That all comes through this stuff here. That also brings the signal in from the generator, which would come down this port here that livens up this power supply, which can switch the relays. This one here goes to this barrier strip here, so I can connect external circuits up through the front there by hard wiring. Interesting, two different methods, but this is going to be for the lighting circuit and this is going to be for the 120 volt AC circuit. It's still got the delay circuit, but I got rid of the Darlington power transistor and just put a BC547 in there with a 2 kilo ohm separating resistor. Kind of had to do that because the original circuit didn't really work once I removed the filter capacitor. Yeah, I got rid of the filter cap here. That's so that when the power's shut off, the transfer time is as fast as possible. We don't really need a filter capacitor because these relays have got quite a high inductance, so their inductance acts as a filter anyway, so don't really need a cap. They don't hum, there's no problem, so best we don't have one so that the rail collapses as fast as it can and these transfer over when the time comes. So I guess that's basically it really. Oh, this is where the switch originally was on the thermostat when it was the fridge controller. I thought about putting a switch on the lid here that I could manually use to instigate it, but I'm probably just going to let it do itself automatically when the power's applied to it. So for now I've just put a link there. I've left this terminal block here in case I do at some point want to put a switch. I may want to upgrade this with a few bells and whistles, mainly some neons, just to show the status of the various circuits, but until that proves to be necessary, I'll just go with it how it is. So there we go, a pretty full-on project. Oh, this came from JCar. This I found on the road once. This white cord here I actually found on a park in Shannon not so long ago. Yeah, this British plug here came from the Nelson dump shop. It's in basically brand new condition. Got a whole lot of those. It even came with the pin protector and the wiring instructions stuck on there. Amazing, eh? 3 amp fuse in there though. That may not last. They last for a while and then the inrush of switching the lights on and off tends to pop them. So I'll have to upgrade that to something a bit meatier. But yeah, that's it really. Oh, all the earths are, that's what I was going to say about earthing. Yeah, when you're running multiple inverters, it's really important to make sure everything's at equipotential. So it's not so much that you've got things hooked to a stake going into the ground, it's that all your earths are bonded together so that frames can't get to different voltages. So therefore, these green wires here are earths for all the cables that are going to be coming into here, and they're bonded using this acorn from here to here, so all these circuits are bonded, and of course they're bonded in other places as well. I bond the earths wherever I can basically, so if you've got everything bonded together then nothing can raise in voltage against something else. Like I say, quite important when you're running multiple inverters. Oh jolly gosh, and I didn't show you it in operation. Here's a test run. The top relay will close, which will illuminate this little trouble lamp. It's a small trouble lamp for small amounts of trouble. And then the bottom relay, after a short delay, will close. So there we go. Relay number 1. Relay number 2. And of course we pull the power. They both go together. So there we go. Day 950 off the grid.